Hello, and welcome back to this tutorial series. In this video, we will be working on our watch a bit more. We will animate the arms for the hours, seconds, and the minute to show the correct time, as well as animate this little spring and the spinner in the back here. So let's double check we have everything we need and then start right away. Right-click on the scene node to uncollapse it. Here you can see the axis nodes named hours, seconds, and minutes. To double check these are correct, we can open the free flight menu by clicking the render window and hitting tab. And when we go through these, we see these meshes behind are getting highlighted, which is perfect. So we want to animate these to show the correct time. For this, we first shift-click all of these axes to get them in the content editor. Now the first thing we are going to do is offset the arms, so all of them show the 0 or 12 o'clock mark. This makes sure we can then later use a 360-degree angle on all of them to correctly animate those. For our hours here, we can see it's right around 46 degrees that we need to adjust. Let's see for the minutes as well. This needs to be on 157, and for the seconds, we need to change it to 109. Now, we have everything straightened out and we can start working with it. Since we now have all these offset values here, we need an axis behind all these axes. So we can actually then rotate in a 360-degree value. Let's start with the hours. Just insert the axis behind it and name it HR. Then we will use a new node, hit spacebar inside the content editor, and then search for the datetime node. On the output side, you can see we have the hours, we have the minutes, and we have the seconds. To make our life easier, we actually have to convert something. Right now, this is a 24-hour format, which means this hour value will go from 24 to 0, but we want to only go from 0 to 12. For this, we have a neat little node, which is the convert to text node, which lets us format certain values. Let's bind the date time to value 0. Now we have the full string here and we can format it. Double-click here, and we will type a colon followed by HH. This will format it to using a 12-hour clock from 1 to 12, which is exactly what we need. Another new node we are going to use is the clipping node. This is a math effect node that remaps a range of input values to a new range of output values, and that we will use to convert the hour value to a 360 degree, which we then can use to correctly animate our watch arms. So our input in this case will be hour to text node, giving us the formatted hour value. The minimum input will be 0 and maximum input will be 12. And for our min out and max out, we want to choose a min out of 360 and a max out of 0. Let's see where this gets us. Click on the HR axis, and let's double-check which value we need to animate. X and Y both are rotating on the wrong axis, so let's bind the Z value to the just configured clipping node. And you can see it's perfectly pointing on the full hour. Normally, the hour arm will gradually move to the next full hour, and not jump from hour to hour like ours would do right now. So to fix this, we need to add some extra angle for this. And what we will do is basically convert the minutes values to a 30-degree value that we can add to our hour value. Because these 360 degrees divided by the 12 hours means every 30 degrees it points on the next full hour. So insert another clipping node, and this one we will call time adder. In here, we will bind the input to the minutes. The min input will be 0, and max input is 59. For the min output, it's 0 to a maximum of 30 that we want to add. The last thing that we are now going to do is subtract this new value from our current one here. Since we are going from 360 to 0, we can't add it but have to subtract it to have it move in the correct way. To do this, we are grabbing ourselves an integer expression node. They can be thought of as mini C# functions and follow the C# syntax. In this expression, we'll take A from our first clipping node and B from the newer one, and we will just say A minus B up here in the expression property. This on the output side is now the corrected rotation value that we need. So let's see if it works. First, we need to delete the current binding to the axis. To do that, click on it and click on the small x, delete the binding. Now we can use our corrected value from here. And as you can see, this now moved over a bit, which is perfect. Now we just have to do this to the seconds and minutes as well. Again, insert an axis here and call this one sec. Let's do it for the minutes as well. Name it min. Shift-click all the axes so we have everything in our content editor. Now we can connect the seconds to a new clipping node. Again, we are clipping these values to the 360 degrees. For here, min out and max out will be again 360 and 0. The input will be seconds, and the minimum in is 0. Max in is 59. Now we can bind this to the rotation value on the second axis. For our minutes, we can do the same. Insert a new clipping node, bind the minutes from the date time to the input right here. The min in will be a 0, and max in a 59. And again, 360 to 0 on the outputs. Bind this to the min axis, and that's it. We now have a fully working watch. The last thing we are going to do is animate the spring and this little spinner behind it. So let's double check where the mesh is in our hierarchy editor. I'm going again into free flight mode and I'm double clicking the mesh. This is the little spinner that we want to animate. It is also highlighted in the hierarchy editor. Let's rename the axis we are going to animate in order to find it better. I will call this one spinner. To get out of the free flight mode, just hit tab again. Okay, now let's see which value we are going to use. As I rotate this value, you can see there is some wobbling going on. If you take a look on the scaling value, you can see that these are not the same, which distorts the mesh. To fix it, we will unify them to 0.5. And if we now spin it, the wobble is gone. For the animation, we will use a node called mover. This node generates an output value based on one of multiple available functions of time. It can be used to create simple animations like rotating an object by binding an axis node's rotation property to the mover's output, or to animate any other property that accepts an integer value. So for the properties here, we want to go between 0 and 360 with a duration of a couple seconds, and change the function from linear to sine. Now we can bind this to the Y rotation value of the spinner axis to let the node animate the mesh for us. Perfect. Let's do the same for the spring. I'm scrolling all the way up here and searching for the spring, which is here. For this, we can use the scaling to animate it. But first, we need to check for the minimum and maximum values we are going to need. For me, the start would be on 0.9 and go up to a value of 1.4. These are the values we are going to use inside another mover node. Insert it again into the content editor and change the properties to a 0.9 and 1.4. Increasing the duration a bit and changing the function from linear to sine. Now bind it to the scaling property of the spring axis. And there we have it, a fully animated working watch. Let's double check how everything is working. As you can see, we have one slight problem here, which is that our slider is actually going through the mesh here. In order to fix that, we have to bring this slider further to the front of the camera. That means we need an axis in front of the slider and then use the Z value to bring it up further towards the camera. We will also have to adjust our X and Y values. And then we are just scaling it to the new environment here, moving it again to make it fit. This should fix the problem. As you can see, the slider is now not stuck inside the wristband anymore. Great. This was the third video in this tutorial going deeper into handling values and animating things without the need of a single keyframe. In the next video, we will learn how to make a fully functioning dynamic lower third out of a Photoshop file.